Hello, welcome, good afternoon, good morning, wherever you are. I would like to welcome you to our webinar, the second part of the Simple Vision training that Stefan Ambus and Deb Eschenberger are doing. So I hope that you either saw last week's webinar or watched the recording afterwards, because this is now just building on top of the webinar last week. And it's also preparation for next week's Identity Vision workshop, which will be here in Auen. Everything is already prepared, so this video will be the last push you need for next week's training. Yeah, I just want to point out that you, as always, you have the possibility to ask your questions. You just need to write them, please, into the question box. We will answer them in between the parts of the webinar. So all the questions will be answered during this hour that's coming. And when it's finished, we will put the material, including the videos, to the course in the Academy. So you can later on do the stuff again and try as long as you need to be an expert in Simple Vision. Good. So now I'll change over, leave this spot, and wish you all a very successful and interesting webinar.
Yes, maybe you will start.
Yeah. Thank you, Andrea, for the introduction. So together with Stefan Ambus, myself, will present you the latest information about the Simple Vision. So the second part, as already mentioned from Andrea, we will start up with some fundamentals about the vision sensors and what is important about resolution, lenses, and so on. And in the second half, we will show you some applications, real applications. We did some videos, and we will show you the videos, how it will work, and then you can see really nearly live how the application works. So I hand over now to Stefan, and Stefan will start now with the presentation.
Okay, hello everybody, also from my side. Now let's jump directly into the topic. So unfortunately, I have to start with some basics and some fundamentals, but I think this is important to understand what we are talking later on. So please, sorry about this, but this is something, from my feeling, I think this is a must to go through. So first of all, I would like to answer some questions which I receive frequently. First of all, where can I download, where can I get the new release from the software? And there are different options. One option which I like to point out, so you can open the Software Center app and then you can download from the Software Center app, you can download the latest release. And the latest release, so this is 23.1.23.29. So this is the latest release. We launched this release just in the beginning of April, and it was announced in the last WhatsApp. Also, there was information regarding the new features, and also there was information where you get a complete description for the new release. However, there's a second option also to download the software from the website. You know, always in a product website, you can also find the configuration software, and this is also the latest release. And then there's also a download option in GSN, and you have a link over here when you click this link later with the presentation. So you will find also the new release. If you installed the software, so then this is already finished, but if you start it right now, so you have to care about licensing stuff, and there are two options how to do this. I would recommend that your computer has an internet connection when you install Vision Studio, and then you get automatically a license key. If it's not having an internet connection, you need a license key, and you have to call us, so then we can provide this key. There's also questions which I received frequently, so this is regarding documentation, and there is 3 different steps or different levels of information. One is provided with the sensor, so this is a leaflet. with basic information, basic instruction, basic technical data, but not with the operating instruction. The full set of operating instruction you will find always if you install and if you open Vision Studio, and then you click on the help button, and then you are linked directly to this site, and you get the information that you can read it online as an HTML file in your browser, or you can download the complete instruction manual as a PDF. And the PDF is always related to the language which you selected. And if you selected, for example, English, German, French, in the meantime, we also have Spanish, Italian, French, Korean language. So then the full instruction manual is also related in the language which you selected on your Vision Studio. And this is the full set of information. Beside this, there's also a help instruction inside for each function. If you are in a function, if you click the question mark, so then you get an online help instruction, and this is a part of the complete instruction. So this one, I highly recommend that you download this somewhere in your language. So this is a full set. If you work with Vision Studio, you get always only a part of information because it's too much to show all the details. However, there's also an option to download it from GSN. We also put the English and the German version in GSN for your download. So some also information, I think it's important. We have some images in the installation files, and you can load these images into the Vision Studio emulator, and then you can work with these images. These are basic images to start using some tools and to start understand how the tool is working and how you can use the tools later on. You will find these images in the installation directory. So this is the installation directory. If you open Vision Studio, and then you will find position 4, Vision Studio Emulator Sample Images. And here are 3 subfolders, and this is what you can see here. So this is a subfolder targets. So you can use these targets and you can make first trials working with the emulator, and you load these images into the emulator. Also, I put this to GSN. Also, you have the link here, and then it's also possible to download this from GSN. We have these cards also as printed cards in the meantime, and you can do the same evaluations with the camera. You start with the emulator, for example, and then you are using these cards, printed cards on a carton, a little bit thicker paper, so stable, unshiny surfaces. So this is good for your evaluation. And we will put these cards into the demo cases. Those ones who already have the demo case will receive it a little later. So we will find out who already received a demo case, and then we will ship these cards to these colleagues. Also, these cards can be found on GSN for your, if you like to print it out by yourself. So then you can use also this link. You can find the PDFs here, and then you can also download it and print it out by yourself. The right is the right image. So this is a calibration grid, which is used for calibration of the camera. So there's in the new release, we have the option to make image correction and to provide image correction data, and also to work in millimeters, not only in pixel. And for doing this, you need a calibration, and you need the calibration kit. So this is also available here. So then some basic expressions regarding an image processing system and everything which is highlighted here. So this is somehow important for your daily work, and I would go through this piece by piece. After this session, we are jumping into the VC tool. So this is a tool which we designed especially for your use to make easy kind of evaluation and to find out how you should set up a camera and how you can decide what is the field of view and the distance, working distance, and so on. So now let's look first for the working distance, and you see the working distance is mentioned here. So this is a distance from the lens to the object plane, and you see there is always an opening angle. Maybe you know this already. And if you are far, the opening angle is always the same, but if you are far, the field of view, the image which you can capture, is larger than if you are close to the camera. This is shown here. We have the field of view, and the field of view always has two different values. So there is a horizontal field of view and a vertical field of view. And for example, if the camera is aligned like you see here, so then this is a horizontal field of view and the vertical field of view. And always you have a higher number of pixels in the horizontal field of view than in the vertical field of view. This is the most important value. Sometimes we are only speaking about this value, sorry, because this is the most important value, and the other value, so this is always related to this horizontal field of view. Here you see for a lens with 8 mm focal length, you see the different field of view related to the working distance. If you are close, field of view is small. If you are far, field of view is larger. The red line is indicating the high resolution model, and the black line is indicating the low resolution model. Okay, and the field of view, so this is mostly related to the resolution of the imager, to the focal length of the lens which you are using, and also to the distance. So these three parameters are important for doing this, or for changing working distance and field of view and so on. We will see this later on in the VCT tool. So then we should talk also about the depth of field, and to understand what is the depth of field. So I put first of all a lens over here. So this is our lens, and we have the focal length 8 mm. We have a 3.6 mm length. We have a 16 mm length and a 25 mm length for longer distances. The 8 mm is the default length. All devices are coming with the 8 mm length. And there's a second data on the lens. So this is the aperture. And we have two different apertures. We have an aperture of 4 mm and 8 mm. And now let's see what is the difference between 4 and between 8. So if you look for this graph, so we have a small f number, which is a 1, but we have a large hole, pinhole inside the lens. And on the other side, we have a large f number, but we have a small pinhole inside. And now the difference is you have a small depth of field on the low side here, large aperture. And on the other side, we have a big field of view. And what is it, if you look for the image, how is the image different with a large depth of field or small depth of field? So then you can see this here. With a small depth of field, you only have a focus and a sharp image on an object which you are focused on, and everything which is in background or which is in the foreground is unsharp, and you will not see this clearly. This is a blurred background and a blurred foreground. And on the other side, we have a large depth of field. We can see the background and we can also see the foreground. And sometimes for some applications, this is important to have a large depth of field. Please think about objects which are running on a conveyor, and sometimes they are far to the camera, and sometimes they are closer to the camera. You cannot change the focal length because the focal length is fixed. But if this happens, you need a large depth of field to be sure that you don't get a blurred image if this is more far from the camera, the object, or if this is closer to the object. So this is something which is important to understand. And we are offering a normal, let me say, a normal aperture for a good, let me see, range, but not so long. The depth of field is not really very large. If this is an issue, so then I recommend to use the aperture 8, which has more depth of field. So you can compare these two images, and you see these images has a more depth of field. So for this application, if there's a always changing distance in the application to the camera, so then this is important to know. So talking about resolution, so then finally the resolution, this is a resolution which is fine. So you have two lines, a line pair here, and you like to differentiate and you like to see both lines individual. If this is coming to a minimum, so then maybe it looks like this one. You have a very small gap in between. And if you look on the sensor side, on the imager side, there is no pixel in between. So this means you cannot differentiate, you cannot distinguish between both lines. Both lines are together, and this is a black rectangular area. So always the sensor needs a white pixel in between to distinguish between the two lines. If the two lines are too close, you cannot distinguish it. And the resolution is depending on the number of pixels of the imager, on the magnification of the images or of the lens finally, and also the quality of the lens is highly important to this. This is just to let you know, you cannot change this because this is given. We have a given set of cameras, we have a given set of optics, but just to let you know what we understand on resolution. So I think more clear to you would be maybe these examples. You have a same image with a low resolution, with a VGA resolution, and with a high resolution. And here you see clearly all the details. And if you make evaluations, maybe to find out if a component was placed or is missing, or if you like to read codes or stuff like this, so then you need a high resolution. This is not sufficient here. So coming back to this slide, we already had this slide, but now we have to evaluate exposure time, because this is also something which is important. Maybe those of you who did as a hobby photographing, so they know already a lot about this. But coming back to the aperture, so you see we have or I was mentioned, this is a large pinhole and this is a small pinhole. And now you can evaluate, or you can understand easily that if you have a large aperture hole, more light is going into the camera and is received by the imager. And if you only have a small light, a small pinhole inside the lens, this pinhole is here inside. So then you need more light to get a really bright image with a good contrast finally. And now this has to be set with the exposure time. Large hole, less light needed, and you can work with a short exposure time. Small pinhole, more light is needed, long exposure time is needed, or additionally light has to be used finally. And if you have an object, for example, and this is the important thing for us, if you have a moving object, think about once more the conveyor, and you have an object moving on the conveyor with a specific speed. So then you have to be sure, or you should make sure that you don't get a blurred image by too long exposure time. And if we have, for example, if you have the object here, so the object is a human body running maybe, and then you have a small f number, large pinhole. You have a very short exposure time, which is 1 millisecond only. So this is 1 divided by 1000, so this 1 millisecond. On the other side, you have a large f number, you have a small pinhole inside, you need more light and you need more exposure time. And 1 divided by 4, so this is 240 milliseconds. So this means your exposure time is 250 milliseconds. And if the object is moving now more than maybe 2-3 pixels within the time of the exposure, so then you get a blurred image because the object is moving, you are still on the capturing side, and then you get a blurred image, and this should be avoided. I think this is the basic understanding behind this. This is why I repeat this, because this is important for us. Now, another thing which is also quite important, so this is ROI, and what does it mean? So the ROI is the region of interest. Okay, everybody knows this maybe, or most of you. This is an area which is decided inside a field of view, and the sensor is only making an inspection inside this ROI. And the big advantage is, can be seen here, we have a large field of view. We don't have specified an ROI, and we are looking for a code reading, or we like to read a code inside the field of view, the complete field of view, without having any ROI. So then for this code here, a C39 code with these dimensions, so the cycle time for the high resolution model, so this is roughly 70 milliseconds. And if you are doing the same and you are reducing the ROI to the size of the code, like seen here, so you see there's a green frame round to the barcode. So then the cycle time comes down to 26 milliseconds. So you see this is roughly a third of the initial time with a large field of view if you only have a part of the field of view. And the background behind this, so this is the decoder only has to evaluate the small field of view, less pixels, need less time to evaluate. It's really highly important to do this. Later on, you will see also an example for this. Okay, so this was the first part about the basic stuff, and now we have to look inside the VC tool, and I would like to show you some slides from the VC tool. The VC tool, so this is created especially for design purposes and also for evaluations, and also to find out what is the right setting for the camera. You will find some more detailed information in the README information in the GSN, also mentioned here. But now we are going directly into an application, and we like to solve this application now by help of the by use of the VC tool. What you can see here, so this is an application which we just finished for the Interpack trade show. And we have an exhibit blade, so this is roughly 450 millimeters, a square blade. We have a code reader over here, as you can see here, and we have two objects which are rotating on the turntable with a high speed. And on this, the object, so this is a stack, contains of 3 packages, and on the packages we have packaging labels. And on the one side we have 6 codes, like shown here, 3 barcodes and 3 data matrix codes. And on the rear side, we also have codes, but only 3 codes. We blocked and we hide all the 2D codes. So 2D codes are not available. So, and now the task is we have to set up the application, and we have to switch on a green LED if 6 codes are in the image. And we have to set up a red LED if it's not, if there's less than 6 codes in the image. What is given, the given data, for example, so this is, we should use the basic default lens with an 8 millimeter focal length. Our barcode module size we know, so this is 0.25 millimeter. The data matrix we know also, this is 0.4 millimeters. And then we have the stack dimensions, which are 75 times 89 millimeter. And now the question is, what should be the right distance here to cover the complete image with a complete stack, and which model we should use, high resolution or low resolution model. So now we can jump over to the Excel sheet, to the VC tool, and it's already opened here. And now the first thing is, where's my mouse? Here we are, mouse pointer. Okay, so the first, I think the very much important folder, so this is setting and instructions. So please open this folder and go up here, and here you can change your language. Currently, we can offer English language, German language, Chinese, and Korean language. We will have an update scheduled for the other European languages like Italian language, Spanish language, French language. We will also integrate Turkish language. So then hopefully we can cover, and we can, so you can also find your language, and you can easily understand better the contents of all these different working sheets. This means if you change any language, all the text will be changed automatically in each folder. So this is completely linked. The only thing which is remaining in English, so this is the name of the working sheets here. So this is the only thing in English which you should remain, or which you should keep in mind. So I will go for the next one, which is important. So this is the specification sheet. And here you can go through, and you have a lot of information which you can put here. All information which are related to the project, finally, application data, like what kind of industry is it, what kind of segment is it, what is the conveyor speed, like I talked already about, which part is, what is the cycle time per time, for example. Do you have one large object running fast, or do you have 10 small objects running fast? So this is complete different stuff. So this is something which is important. And then there's also a lot of other things about what kind of objects should be evaluated. Is it shiny, having shiny surfaces? Is it upright? Is it metal? And so on. So I think this is easy to understand. So this is something which guides you through a conversation with your customer. These are questions which you should ask. And the more information you put here and forward this information, you can print this out, you can store this, and then you can forward this information to your service guys for supporting you. And I'm sure the more information you can provide, the better you get support from the service guys, because most of this information we need anyhow, because otherwise you can do really a good evaluation. So there is some drop-down menus. There's a date picker integrated to make it more easy, not to have too much to enter here. But I think this is something which you can read through, easy to understand, put the data, talk to your customer, ask these questions as most as possible, and then we are happy to help you. Something for your evaluation, I think, and this is what we start now. So this is the working distance sheet. Here we can calculate working distance and field of view, which is related to the working distance, or vice versa, it doesn't matter. So now remember back, so we said our object size, so this is a length of 89 millimeter, and it was a height of 75 millimeter. So we put this here, and now you see already a change in the diagram or in the graphic here. So this is now our object. So this is one thing which you can enter here. Now we have to make the evaluation. Does our field of view fit to this object? And maybe some of you already listened to the last presentation last week, and I suggest to start always with the low resolution model and with the low toolset model because of economical issues or economical background. So everything which is red highlighted, you can enter values. In all other cells, you cannot enter any value, so this is blocked. And something which you can change, so this is with a drop-down menu given. So here, for example, we can select the sensor, and we have two different models. You know this already. We have the low resolution model with the resolution mentioned here, or we have the high resolution model. And we decided to start with the low resolution model. So now we select the low resolution model, and you see it's changing online here. And then we had the task, we should start with an 8 millimeter lens. So then we select the 8 millimeter lens. And now see what happens. We have a field of view, and we have an object size, and this doesn't fit so fast. What we can do also, we can move this object inside this window by clicking these. We can take this point here, this edge point, and we can move this edge point into the window. So we can do this over here. So we click here with the slider and we move this now, try to get it right into the middle of the field of view. Okay. And also we can drop down slightly. So, but what happens now? We have an object size which is clearly larger than our field of view. And so we have to change this and to make sure that our field of view is larger than the object size. Here we can change now the working distance, and our field of view is calculated by itself automatically. So now use the slider and maybe we go up to 300 mm. And we see even with 300 millimeter working distance, our field of view is still smaller than our object size. So maybe we try to 350 millimeters. Okay. So 350 millimeter, and we can move this once more back right in the middle. So I think this could fit if you don't have codes right in the corner. So because then you are close to the edge and you should not work close to the edge. You should always have a little bit space which you are not using to make sure that you really can read without getting distortion in the edges of the image. But at least we should go with a distance of 350 millimeter. Now think about our blade was only 450 millimeter and we have not space for having this kind of working distance. So our first result is low resolution would not work. We have to change and we have to make the same evaluation with the high resolution model. This can be easily done now. We just select high resolution model. And now you see, if I don't change working distance, now you see we have a clearly larger field of view than our object size. But this is not really helpful. Even we have to decrease working distance. I will drop down to 200 millimeter, see what happens with 200 millimeter. Looks not too bad, but 200 millimeter is still too far for our small exhibit blade. So I would try to go to at least 160 or even less. So I try to look what happens with 160 millimeters. And what I can find out, I can also move this right in the middle a little bit. This would fit, I would say this would fit perfect because our codes are not in the corner. So they are somewhere here and also somewhere here. So then we have a large field of view, which is pretty much enough. So this would be a great setting, which I would recommend. However, in the exhibit, we also don't have 160 millimeters, so we had 150 millimeters maximum. And then it looks like this, and we have a little bit an overlap here, but for my evaluation, I said, okay, I would try if this is reasonable, if this works, even if my field of view is slightly smaller. But as I mentioned, we don't have the code on the edge. We have the code not directly in the corners. Okay, so this is the first approach. We find out now we need the high resolution model because field of view. And now let's double check what is the resolution which is required because of the code reading. And for doing this, we can use another working sheet which is called ident. And now we see pretty much the same, but you don't have to enter it once more. So now you can click on these buttons here, and you take over values from the previous working sheet, from the working distance. You see, this is take values from working distance, the field of view, take values from object data. Now we have the same diagram here, and maybe we can move it a little bit high. So, okay, now you see this. Okay, so field of view is given, and now we have to evaluate what should be the resolution because of the code. We had a 1D code. We can select a 1D code or a 2D code here. And then we can also select, is it a code given in mil size or in millimeter size? It was millimeter size. And if you remember, so it was a 0.25 millimeter code. Sorry. So it's a 0.25 millimeters code. And if you change to a 1D barcode, so then you have a default value here. So this is a data which you can change, but you should not change it. Why? We need a dedicated resolution per pixel, and for the 1D code, I would recommend to use 2 pixels per module, and this is the default value. The minimum value which is allowed, which you can try, so this is 1.5 pixels, so you can also slide this down, but please be sure that always if you change to a lower value, your reading performance is also maybe not such high as if you have a higher value. I had a customer talk this week, and this customer, he mentioned he is requiring 5 pixels per module to be sure that the reading is working under all conditions. So this is something given from a customer, or was requested from a customer. But this is his own decision. Our decoder is working, I think, very well, very with a good high reliability with 2 ppms. And then we find the result now already here. You see, we need at least in the horizontal direction, we need 775 pixel, and in the vertical, we need at least 581 pixel. So, and this is now indicating to the high resolution model. This calculation is also showing the same result. We have a high resolution model because of resolution with the code reading, and also because we need the large field of view. And now we make the same evaluation with the 2D code. We changed to 2D code, and now you see it was changed to 3 ppm, because for the 2D code we need at least 3 pixels per module. So ppm means pixels per module. Minimum is 2.5, but recommendation would be 3 pixels per module. And then we have already finished our calculation. We can see we need
we missed something. The cell size you have.
Cell size, sorry. So this was 0.4 millimeters.
Yes.
Okay, I was wondering because of this high value.
Yeah.
And now you see it would work because of the large cell size of 0.4 millimeter. Even with a higher requirement of pixel per module, it would work with a low resolution model. However, we have to use the high resolution model, but this is to guarantee that your application or our application, my application, would work. So this is an easy example how to use the VC tool and how to change settings and so on. And now you can make maybe your own experience. You can try to play a little bit, and you see I think it's really nice to see always the object size and see the field of view and see if this fits or not. So then you know exactly what you do. Okay, I think this is so far from the VC tool. Maybe we can look up if there are any questions so far, because then we jump to the next topic where we like to show you some nice videos and also applications. No questions?
Okay.
But you are still alive, guys. Okay. So, yes, now we start with a video, and I will hand over.
Okay. Yes, Stefan already mentioned, we are showing you nice applications, and this. Yes, they are alive. Okay, thanks. You get this response. Good. Yes, we want now to show you some applications, what we already done, and applications we are presenting on the Interpark trade show next week. And for this, we took some videos where you can see how to set up the devices, how to work with the devices, and afterwards how the devices are running. So first we show an application done with the IVS 1048, and afterwards we will show an application what now we have calculated and Stefan already present with the IVS 1048. So let's start the video here. Milk is not starting. Oh, it's running. This is the turntable with some choco milk on, and you see the straw, and you have to detect this straw if this is always there or not. For this, we have to set up the IVS 108, going in the setup. Now we are looking for some good samples. We are teaching this by hitting the teach button to a second good teach, and then jumping with hitting long time the teach button to the good to the bad one. Now we are teaching the bad one. Teaching for the picture always with a short the time hitting the teach button, changing between the starting, changing and leaving. Always wait until each LEDs are coming. Now the process is stopped, already stored, everything inside. The machine starts with running, and you can see with the signal tower, you can see the red and the green light coming when it's working, or if you have find out the bad one as well. So this is one example, one option. Another option, doing this via our web configuration tool. You have to type in the LEUZE default web address, and then you can go in this and do the same with this tool. So now looking for a new task, creating a new job, and typing in a name for this new job, that you can later on find this job. Store it on a selected bank. We have up to 32 possibilities of banks to store different jobs. Now start the automatic setup when you get the picture. The focus will adjust it, the light will adjust it. If you want, you can optimize the focus distance or the exposure time. This is if you want to do some more, but it's not needed. It's automatically set to the best values. Click to next and going to looking for good samples. Present the good samples and teach this in. So one teach, second teach another position, and a third as well. So 3 good pictures you have now. Click to next, and now we are looking for the bad pictures, the bad sample. Teach in this, also in different positions, that we are quite sure that it works, and then click to train, and the device will set up to this configuration. All parameters are set. Now you are under monitor mode. You are starting the machine again, and now it's running. So the different samples are coming, and you see it will be highlighted with green frame when it's good, and with a red dotted line if it's bad. And the analysis charts automatically calculates all the good and the bad ones. So this is all you have to do, not more, and the application is running. And you see now in this short time, we showed 2 possibilities, either teach by the teach button or teach by the web configuration. Both is possible in this very short time. You can also combine this. You can start with teach button and later on optimize with the web config. Both works. And now you see the machine is running. The model is prepared for the exhibition, and we can go to this with the trade show. This was the complete configuration. You see the time less than 4 minutes with all the stuff around, with starting and with ending. So I will expect that you can do this in 1 minute, teaching, and everything runs.
No, but,
Okay. So now we coming to the next.
Yeah, maybe
you want
some comments from my side. I really like this sensor because it's really so easy. And you see, Gert showed you and explained this. You have two options. You can press the button and you can set up everything without having any computer and so on. And you can also, by pressing the button, you can also read in maximum 6 images.
Maximum 6 images.
Minimum, you need a good image and you need a bad image.
Yeah.
It's always required to have both. You cannot work with just one image and say, okay, this is a good image. Now, what is the decision for the bad image? So this is not possible. You need always a good image and a bad image. And hopefully you have seen when changing the position slightly, you can get a better reliability, slightly the position, and read in a good image and a bad image. If you would only teach it in one position and you have some differences, so then maybe it would not be so reliable, but you have the option to say, okay, I take 3 good images and 3 bad images, or I can say I have mostly good images or mostly bad images, and then like to differentiate. And so then you can say, okay, I store maybe only just 1 good because it's so clear that it's good, but I have 5 not okay images. So then you can do this in this way. This is really the nice thing, and you can start working, and then you can also, I think you can also change from one folder to the other folder.
Yeah, for sure. You can do this afterwards and jumping in again and optimize this.
Yeah, yeah. To find out if this is now reliable. Also, you can change a little bit the object distances and so on to find out if this is reliable. But believe me, the straw is never on the same position in this exhibit, and also the trigger position is not that precise as I wish it would be. Anyhow, it works very well, and so this is really fantastic how this sensor is set up into operation within a very short time.
Yeah.
Okay, so I think now we can go to a second exhibit. So this is this one which we already talked about, which we make the calculation, and now we can see how this is solved within the DCR 1048. So we have also prepared a video for you, and we can start the video. So I click here. We see already the stack here in this turntable. We see the trigger sensor, the camera over here, and we see the light. And keep in mind, we have to read 6 codes on each side. Here you see the barcode. You see the blocked 2D codes, so the hidden 2D codes. And on the opposite, we have 6 codes, we have 3 barcodes, and we have 3 2D codes. And our task is to set the green LED and the red LED accordingly. We start Vision Studio, and here we are working with emulator mode, but it's similar if you are working with a camera connected. You select the right tool set, you connect the emulator or you connect the sensor, and you start with a new job. You open the new job, you rename the new job, and then you can store it and you can confirm the new name, and then you are opening this job. Enlarge the image a little bit. No, it's okay. So first of all, we should decide where we have images to load from the PC into the camera. So this is given with the image directory, and here you see this is now the first image which was acquired, which was captured directly with the camera from the exhibit. I download these images and I'm using these images for the evaluation now in the emulator. And this is similar if you work in the emulator or if you are working in the camera. Images are the same, so because they are directly coming from the camera, they are stored by the camera, and I download it to my PC. I start using a count tool. Now see, I make a first decoder, and I adjust the decoder only on the size of the 2D codes. I try to keep it as small as possible because of timing. So this is what I mentioned earlier in my presentation. Try to reduce ROI as much as possible. I have to identify the code. 3 codes are already read. And then I said, I like to count minimum and maximum 3 codes to make sure that we always have the 3 codes inside. I take a second decoder and I make the same with the 1 decode, just to make a very small ROI to make sure that it's running fast. Identify the code. 3 codes are already read. And I also make a specification. I like to read 3 codes minimum and maximum. And now we have 2 decoders. Each decoder is able to read 3 codes in one shot, one with the 1 decode and the other one with the 2 decode. You see, I have a free run mode now. The images are changing frequently, and you see the 2 decodes. Always one is missing on one side, and on the other side we have the 3 codes. So now we have to set up also our output, and to doing this we go for the logic in the next step. And to set up a logic with digital outputs, we go for the logic. We click on the folder digital outputs, and the camera has 4 digital outputs, and now we use digital outputs 0 and 1. 0 should be the green LED and 1 the red LED. I'm using the 2 tools, and I use also a logic and I put both outputs together. I put a logic and function here. I said, okay, I take code reader number 1 decoder, number 2, and the output, if the output is 1, my green LED is on. That's right, because both decoders are reading 3 codes. In total, we have 6 codes, green LED, so this is okay. Red LED, so this is always just an inverted function. If it's not green, so it should be red. So this is why I take the output, put it to a not function, and then put it to the output number 1, and this is the red light. Now the configuration is finished. We can now switch on a green LED if we read 6 codes, and we can switch on a red LED if we read less than 6 codes. There's also a nice option. You can add a comment into your diagram with your parameterization or with your configuration or with some ideas behind your configuration or behind your design here. Because if you double check it maybe 3 weeks or 3 months later, so maybe you lose something which you had in mind in this time. So sometimes it's helpful to make a comment here. Then you have a nice documentation already. You can store this, and if you recall, you have all available. So there's one comment for the green light, and I think so there's the other comment for the red light. If you like to use it or not, so this is up to you, but I would recommend always to make even more documentation. Also, if you get it maybe to your colleague or to third parties, so sometimes maybe they don't understand what is your approach here, and then you can highlight your ideas and also your approach and give this information, pass this information also to your colleague. If you establish or if you design a job in the emulator, you can upload it to your PC, and later you can download it to your camera, or vice versa. You can design a job in the camera, and then you can upload it to your PC, and you can download it into the emulator, and you can make evaluations wherever you like to do. So this is a very nice feature, and everything which is available in the camera, so all these tools you have in the emulator also. And this is normal, the traditional way how to start. You have some images, you take these images, you make pre-evaluation, you find out it should work, okay, so this is a kind of a feasibility study, and then you go for the camera and you look for the real world if this is really working. Okay, so I think maybe we are through this one. So this is missing. So I think there's some. Okay, so then we have maybe this last part here. So you see now we set up everything fine. We have the green light, we have the red light, which is always alternating, and see the speed, which is really the real speed, which is displayed. And this is because of these very small ROIs of the decoding areas. So we have a second video, I think, for you, which is also an exhibit for the Interpack, and this is an application which is solved with the IVS, and this is a label inspection. We like to see if the label is aligned in the right way or if there's a misalignment of the label of these bottles. So we will start also with a first setup that you understand the application. We have also the turntable, we have 4 objects, everything is the same. And now we start with our video. This is just the beginning. You see nothing is set up. The LEDs are not flashing from the light. And then we are starting same. So let me enlarge. We take the emulator. This was the emulator, the IVS TPRD. We connect the emulator. We open a new job. We rename the new job. Whatever you like is possible. Here I change label inspection, commit, confirm, and then open the job. And in the emulator, always you have first to decide where are your pictures, what is the image directory. If this is selected, so then you can connect it, and then you can click on override, and then you trigger once, and you have the first image. And you see the image. This is a bad one. This is a good one. This is a good one. This is a good one also, and this is a bad one. And we like to find out the bad one out of the good ones. So we have 3 good ones, and we have 1 bad one. Now see how this can be solved. I took the locate edge tool out of the tool sets on the top, and I set the locate edge tool that we can detect the edge on the label, which is behind or up to the white area on the label. So you can see this, and if this is angled more than 190 degree, for example, so then we can say, okay, this is a bad one and this is a good one. You see the angle is displayed here, so we have an angle 181, so this is good. 193, this is a bad one, and this should be pushed out maybe later on if there's a process. This is 189, so this is still okay or not, so this is up to the decision of the customer. But this is the task now. Just 1 single tool, edge detection tool, and the angle is used as a measurement. Here I took the locate edge, and from the locate edge I can take the angle value, and I will take also now a rhythmic tool, a compare tool, and with the compare tool I make the differentiation what is a good one and what is a bad one. Now see, I connect the output to the input of the compare tool, and I set my threshold. The threshold is 190 degree, and I set everything which is smaller, the operator is smaller than 190 degrees, so this is a good one. It's a green LED, output number 1, output number 0, so this is a green LED. Now this is already configured. Now I need the second, I need the red LED, and the red LED should always be on if this is more than 190 degree. So I take a second compare, and I set larger or equal to 190 degree. And if this is the topic or if this is the situation, so then I should have also a light signal, and the light signal, so this is red light. I also connect the output. You can connect several signal passes from one point to another point, like shown here. And then the output goes to the output number 1. And now the output configuration is done. So now we have a green LED every time if we have less than 190-degree angle, and we have a red LED every time if we have more than 100, more or even equal to 190 degree. So that's it. So this is, I think, also very nice, very easy. For sure, you can get all these values through the TCP/IP interface. But in most cases, I think in most cases, the vision sensors are working with switching outputs because customers maybe are operating a process with a good and with a bad signal. But both is available, both is possible. So this is the free run mode. So this is similar like it would happen in the on the camera. You see this is running through, and the edge detection tool is detecting the angle. You see once more the difference in the size of the angle. This is the bad one, so this is maybe still the good one, or could also be a bad one. But it's really very nice to make the design here. We will upload these images also for your reference. If you like to repeat or you like to make your own exercises similar to this one, you can load the video, you can run the video, and you can make the exercise by yourself. So this is why we provide also these images to you, both for the code reading and also for this label inspection. So this will be later on the Academy folder. Also, we will provide the videos to you, and for sure the PowerPoint, which I showed, and also the VC tool you will find in the folder later on. So I think this is now I think this stuck a little bit this video, but anyhow we can look if there are some questions to answer. No questions. Okay, so. So then I think maybe we can finish this. Yeah, the last sequence here, which is now not missing. So, but this is coming too late. So this is now you see in the turntable once more, and you see the red light and you see the green light. But for sure, you can imagine how this is looking. I think hopefully you find something interesting for you. You have some ideas how to work with the sensor. Also, you can look through these short videos once more as a kind of a training videos. Also, this was the intention why we did these videos for yourself. They are not so long, so just 5 minutes, and then maybe you try to repeat once more your exercises by yourself, or maybe you just repeat it and you understand everything from the video finally. Okay, so then if there are no more questions, you like to, there's one thing which, because of a very, is it still open, Andrea?
Yeah, but we should come to those.
Yeah. There was one thing which I like to, if you received a camera, you will find a large cap on the camera, and if you remove the cap, don't turn it by 630 degrees, just turn it by 10 degrees and remove it slightly. And then you will find inside maybe a small black cap on the lens. Every time if you have a small image, a black image, you have this cap not removed. So please think about this, because I just got a call from a colleague and he said, I only get a black image. So please, if you receive a new sensor, there is always a protection cap directly on the lens inside the camera. Remove the cap outside, turn it only by 10 degrees, not more. Remove it and put it back in the same way. Okay, now I'm finished.
Okay, just yes, have a good weekend. Thank you for joining us. You will find the material on the Academy in the course directly. So see you next week on Monday or on Tuesday after the public holiday. Enjoy your weekend and take care. Bye-bye.
Bye-bye.
Okay,
Have a nice
take care.
weekend. Bye-bye.
Bye-bye.